Alright, today's lesson, we're going to be learning about graphs and no/infinite/one solutions. So believe it or not, we can see these on graphs too. The trend, I don't know if you guys are seeing the trend, but we can basically graph anything in 8th grade math with equations. It's very possible, and we can graph these, or they can be represented by graphs. And I'm going to draw 3 graphs here. We got 1 graph, 2 graphs, and we got our 3rd one down here. And this first one we're going to talk about is a 1 solution. Because in the future, you're going to get a y equals mx plus b equation, and you may get a second one like this. And when you get 2 of them like that, you just graph them. So for example, if and I'm going to be off because it's not grid paper. I actually never grid paper as a math teacher to my house, so that's a problem. But regardless, let's say I have this y equals 3x plus 2 and y equals 2x plus 3. And I'm just going to graph these the best I can. So let's call this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So when I graph these on this one, I'll make it a red line. So I'll put him in a red square so you know which one it is. I'm going to start him at the positive 2 right here. I'm going to go up 3. 1, 2, 3. And over 1 because that's how you graph that. And right here is the line. The next one is y equals 2x plus 3. I'll do this one and let's use purple. So that one's purple. And I'm going to start at the 3 right here. And we're going to go up 2 over 1. 1, 2 over 1. I'm going to graph that. Now, as you can see, both these lines, and I did that a little bit off. There we go. Sorry about that. So both these lines, right, when you look at them, we call this a 1 solution. And this is an awful example, but sorry, just bear with me. We call this a 1 solution because they touch 1 time. And since they touch 1 time, we call it a 1 solution. Okay, so that's how you have to think about it. The lines touch 1 time. They touch 1 time. So it's a 1 solution. Okay? And so let's talk about the next one. A no solution. Okay? Now, a no solution, I'm going to make 2 equations over here. Oh, sorry, I got to zoom out. So a no solution may look like this. Y equals 2x plus 4 and y equals 2x plus 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And so when I graph these right here, let's see, where do I start out in the first one? Let's make the first one red again. I start at the 4. I'll go up 2 and over 1. 1, 2, over 1. Just like that. And the next one, I'll make blue. We start at the 3. I go up 2 over 1. 1, 2, over 1. And what do you notice about those lines? Are they touching at all? The answer is no, right? Let's just be honest. They're not touching at all. So since these are not touching at all, no touch, right, equals no solution. So these are probably the best ways to remember it, at least, right? So 1 solution, 1 touch, 1 solution. This right here, no touch, no solution. And the key word for this that you're going to have to memorize is parallel. And this is going to be a vocab word we use a lot in the future. So when I think about the word parallel, Parallel means two lines that will never touch. And sometimes the lines look like this, and you're like, well, of course they don't touch. Well, remember, lines can go on forever. So if I draw these lines like this, right, they'll never touch. Even if I draw this forever, they will never touch. Okay? So one more time, no touch means no solution. And your keyword is parallel. Parallel, the hand symbols like this. Okay, I know we do hand symbols in class. Parallel means the lines will not touch. Okay, last one right here. We're left with infinite solutions. So, infinite solutions. Now, infinite solutions, I'll get y equals 4, oh, sorry. Let's go y equals 2x plus 1 and y equals 2x plus 1. Okay, and I'll make my little line, make this a little better. Let's see, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now I'm going to draw these lines. First line I'm going to draw is red again. Let's start at the 1. Slope is 2, so we're going to go up 2 over 1. And there's my line. And the next one I'll make blue. Y equals 2x plus 1. So start at the 1 and go up 2 over 1. And whoa, what do you guys notice about that? Okay, and I'm going to make a blue arrow right here and a red arrow, just so you can see it. I have 2 lines there. Huh. Those are touching at all times. And if I keep drawing this forever, are they going to keep touching? The answer is yes. These will touch forever. So since these touch forever, right, these are infinite solutions. And I don't know if you know this, but forever and infinite are basically almost the same word, right? An infinite amount, a forever amount. So kind of keep that as like a shortcut for your brain. Touch forever, infinite solution. Touch no times, no solution. Touch one time, one solution. Okay. But I want us to kind of compare these equations, and this is a little bit more of an advanced concept. Okay. This is where we talked about in class, the word substitution comes into place. So if we have the word substitution, right? That word means anywhere a letter tells me what something equals, I can replace it, right? If I got, and I said this in class before, but if I get sick, someone replaces me and they're my sub. What do you notice about this first equation right here? Okay, let's look at this for a second. Y equals 3x plus 2. So 3x plus 2. This y right here is alone, right? It's telling me y equals 3x plus 2. So I could put 3x plus 2 anywhere I see a y. Okay. Anywhere I see a letter y, I could put a 3x plus 2. Because let's talk about past reference. If I told you x equals 2 on an equation, then you see 3x plus 1, where would you put the 2? You put the 2 right here, right? But just because I added more like this, 2x plus 1, doesn't mean you can't put more in, okay? Believe it or not, you can substitute more than one number into one spot for a variable. So since I just read y is 3x plus 2, I can look at this equation below it and put, okay, I can put 3x plus 2 where I see the y. Here's the y, here's the x. I'm going to put 3x plus 2 where that y is. So watch this. I'm going to move him here. 3x plus 2 in the spot of y. And guess what? The rest of this right here, the 2x plus 3, did that change? Nope, I'm just going to rewrite it right here. 2x plus 3. So in the other video, we talked about looking at equations, right? To see if they're one solution, no solution, or infinite solutions. And this is how this relates to that. If I were to try to solve for x, subtract 2x from both sides, I get x right here subtract 2 from both sides, equals 1. This is a 1 solution because it tells you what x is. You see how that works? So since I figured out what x is, this right here is a 1 solution. X is the number 1, meaning there is one answer for the letter x, or variable. And I'm going to use that same logic over here, okay? And I'm going to go a little faster this time. Y equals 2x plus 4. So anywhere I see a y on the next equation, I can put a 2x plus 4 there. And since the y is right here, I'm going to replace it. And I'll write it on top since I already used the space below. So instead of the y, put 2x plus 4. 2x plus 4. And right here, 2x plus 3 didn't change, so I put it right there. And now I have an equation, and let's compare them. I'll subtract 2x from both sides. Those cancel out, and I'm left with 4 is equal to 3. And that right there, if you watched the video prior or listened in class, that's a false statement. And false statements are no solutions, right? So you guys see how these kind of relate to the last lesson? This false statement, these two lines, don't touch. They no touch, no solution. False statement, no solution. Kind of mind-blowing, right? It's weird how that works. Infinite solutions. I'm sure you guys see the pattern by now. Y equals 2x plus 1. I'm going to put a 2x plus 1 where the y is. 2x plus 1. And this side didn't change, so I'm going to just put that straight down. Equals 2x plus 1. Now, without doing any math, if I see that both sides are identical, they're mirrored, we can assume that is going to be an infinite solution. But I'll just show you regardless. Subtract 2x from both sides. The x's didn't survive. They're done. But I am left with a statement, and this statement says 1 is equal to 1. Is that a true statement? Of course it is. And since it's a true statement, we can declare that this is an infinite solution. And because of that, we can even graph these, like I said before, and they'll touch forever, making it also an infinite solution. So hopefully you kind of see the connection between those two with one another. And in the future, when we do get a little bit more advanced with this, this will be a great starting point for you to understand why we have these. Because in reality, sometimes there isn't a solution to math. And so we got to be aware of that and put it here. And sometimes everything is a solution, right? Every number in the world. So we need this to exist. And one solution, we've been working on that since we started equations. So that's nothing new. Even though I've never talked to you about it, that's always been the same. So hopefully that we are pretty good at graphing y equals mx plus b now. If you can't do that consistently, we gotta get on that, right? Because you're not gonna graph one equation, you're gonna have to start graphing two equations, and we gotta see if they touch once, twice, or never. So really fast, this is touching one time, right? I need a hand symbol for that. What's a hand symbol for that? Hand symbol touching one time is here. We're gonna make it X. Cool. If we are touching no times, the no solution, parallel lines, right? Parallel. If they're infinite solutions, we're going to stack them on top of each other. They're touching forever. Okay? And thank you for watching. I appreciate you guys.
6 7 6 7 6 7 6 7 6 7. Ha ha ha.
And I'll see you in the next video. Thank you for watching.